Hello and welcome to this video. Today we're going to talk about linking movements. This is an important building block to ensure that the simulation in TopSolid matches the result on the machine. We'll look at the different types of linking movements using various examples and discuss when they are especially important. Enjoy! Let's first take a look at what linking movements actually are. For this, I have created this machining operation here, which I will simulate. This means that we have an approach movement from the tool change position to the actual machining. This is one type of linking movement. And after the machining, we have a retract movement from the machining back to the tool change position. So those are already two of the three types of linking movements that TopSolid has. The third would be if I now create a machining operation on another level with the same tool. That means after the first machining, it doesn't return to the tool change position, but instead moves freely. And it would then position itself accordingly for the second level. We can control these things directly in TopSolid. That means I can display this linking movement menu here. I'll briefly close the machining operations, and now I can see here how it first moves completely freely in Z91. Then it moves to a tool change position as I set it. Then it aligns the axis, moves in XY again, and then approaches again in Z. But it could be that I say I don't want it to move up that high before it swivels, because in this case I want to produce 10,000 of these parts. That means I want to optimize the process a bit for time. Then I can simply delete certain movements here as well. To do this, I switch it to manual and delete the two movements. And here I just add a new coordinate movement. I say I want to move up in Z. From the current position, only 100 millimeters upwards. That means starting from this position, I am now at this particular point. Then I rotate the B-axis. Then I want to move in the XY direction, and then I am at the final position. And this way we can actually control the connecting movement directly here. And we have the advantage that just as we simulated here, we actually output impulse processes, and we can then safely move in without basically flying blind, so to speak. A second example of the connecting movement, which looks a bit more complex than in the first case. For example, when we want to machine a pocket here, where we first have to pass by the workpiece with a very long tool. Then we move the workpiece further and then plunge into such a movement. Here, for example, into this component. I can show the connecting movement itself here. That means you can clearly see the individual steps right here where I am now. First, you need to set the A-axis to -20 degrees and then move the tool carefully to the minimum axis value in the Y direction. That means since you have the machine visible in the background, we can also specify both the minimum and maximum axis values there as well. For example, we can also say -1 millimeter, for instance, starting from this particular value. And I can always specify which is now the controlling coordinate system for the individual processes. Then it sets up and positions itself in the center. And then, so to speak, it performs the plunge movement and then moves to the final position. That's one example. Another example could be that I have a groove right here in this specific spot where I have very little space to work with. If I simulate that situation, it means first it moves to the position with the tool. And you can see right away that it first plunges in here with the tool. And then it makes a kind of rotational movement around the tool's correction point so that it can later pass by the component here, because if it went directly into position, it would probably crash. So here, in the connecting movement itself, we also have the possibility to specify a particular movement, which is, I think it's actually this movement here in RTCP mode, which means, RTCP stands for so that it can swivel around the tool's correction point. Because if I were to, for example, remove this check mark now, then it wouldn't swivel like this, but instead it would naturally swivel around the C-axis. Then we would see a movement that looks just like this, which really wouldn't be very good for either the tool or the machine. So we get it simulated directly, output it accordingly right away, and can start working with it immediately without any unnecessary delays. This is a very extensive topic because you can set a lot of things with the linking movements. We can even create rule documents later on where I specify how it should behave in certain cases. In a later video, I will also show or explain the rules again. But for all of this, we actually have a campus course on linking movements, There you'll find really good and detailed information on how to set them up properly, so you can always be absolutely sure that exactly what you simulate here in TopSolid will be output on the machine in the same way without any unexpected differences. And that was a brief but informative insight into linking movements and how they work together. Now we've reached the end of the video. I hope you enjoyed it and that you were able to gather some ideas on how to use linking movements in your programming. Feel free to leave a comment. We appreciate every like. See you next time.